So this session will include the wind definitions, that is the creation of wind definitions in StaadPro. So I will create a new file. This is a file I will create using structure wizard, a bayframe model for a building structure. In X direction, two bays of 9 meter each, that is the total length 18 meter, and height 2 floors 4.5 meter each, and in Z direction 3 bays, and merge the model. And this structure I will use the variable height, that is the walls on the back side. The frame will have an additional height of 3 meter. This column is height 4.5 meter, but in back the maximum height will be of first floor 7.5 meter. That's 3 meter extra. So I will just edit all the nodes. By that all the members will also change, and we will have a variable height building structure. So the wind definitions can be more elaborately explained. I will select the nodes and change the Y to 12 meter, and interpolating the middle rows. So in front the maximum height is 9 meter, in the end it is 12. Interpolating, we will have a 10.5 meter. So selecting the nodes and changing the height to 10.5 meter, that is the Y coordinate. Selecting again, next I will apply the variety of wind loads. The pressure distributions are calculated and converted into forces, which are then applied as nodal loads, and wind parameters such as exposure category, topographic factor, wind to link ratio, and the natural frequency of building. I have applied the supports here. So a brief overview. Under definitions, so in the STAAD we will have to apply the type number, the wind directions, and the pressure. So when the wind is blowing in X direction, we will have three faces of building. Front face where the pressure will be applied, that will be the windward face, or say windward wall. And the back side, yes, this is the front one, this will be the windward wall. The pressure on this walls and frame will be exerted when the wind will blow in X direction, and in the end that will be the leeward for that wind flowing in X direction. And the side walls, there will be two side walls, so like that all the four walls will be covered in these three type of definitions of wind. Wind will blow in global Z direction. There again will be three type of walls. One is windward, another is leeward, and two side walls. As I previously mentioned, the wind parameters, these will be applied to each direction of wind which is being considered. So thus certain prior planning is desired to apply the loads. Now we will consider a sample model. This model, as we have created, just having size data and different heights on front and back side. The first floor is 4.5 meter and second floor is the variable height, 4.5 meter in front and 7.5 meter at end. Now add the code definitions for wind using the wind parameters. Just explaining more. Then what is the direction, which is very important in applying. So once the definition is there, the load will be applied in load cases and then the analysis can be done. So creating wind definitions and understanding their directions. So wind is blowing in the arrow marked in X direction, and this will be the front wall, that is the windward wall and side wall. One I have shown in the positive Z direction. Mean roof height will be the front height 9 meter and back height is 12 meter, that is 9 by 12, that is 21 by 2 equals to 10.5 meter. So while defining, we will be taking the mean height of roof. And this is the once loading has been selected, define load systems in loading ribbon, and I will just name the type of wind definitions. First is the windward in positive X direction. Second is the leeward in positive X, and third will be the side wall for positive X. So this will comprise for the one set of wind load. Next will be the windward in Z direction, leeward in Z direction, and side wall in Z direction. In the next definitions, we will have to use the natural frequency. So we will just assume a frequency of, say example, 2 Hertz that will give to a time period of 1 by 2 Hertz, that is 0.5 second. That means this is a rigid structure, maybe a concrete type with a infill walls or some panel walls. May not be infill, maybe other, but the wind will be applied over it and pressure will be transferred through panel sections to all the framing beams and then to the nodes. So I will just calculate as per ASCE. I will just change the one item here. I can change the velocity, basic wind speed, building structure. Once I will change the one category, the apply button will be highlighted to click. So these are the parameters which are standard in almost all the codes. Here the StaadPro calculates as per ASCE 710 equation 27.3.1, and the pressure QZ is given by this formula. It is written in the StaadPro window also, where V is the velocity and KZ, KZT and KD are the parameters of wind. Once I will select an exposure and clicking apply, so thus the common data has been incorporated. Next is the main building data. Here the most important, this is the formula QZ which I was mentioning. I will have to change the units here because this formula was taking the units in pound per square feet. So I will have to change the units of the building height. So building height, as I have mentioned, mean roof height 10.5 meter. So the mean height L will take 10.5 meter. When windward in x direction, that is the windward walls having direction along the length of wind is 18 meter, and the perpendicular to direction of wind is the dimension of my building, that is 21 meter. Building natural frequency, as I mentioned, design pressure is given by this formula, P equal to Q into GCP, that is coming in next. I will just use the enclosed building, partial enclosed building. These are the parameters I am taking. Now this is the most important for the direction. Once I will just click on the windward, the forces will be generated, and the parameters in the are grade because the code and these formulas have given these GCP parameters. According to that, we will get at the various height the pressure. We can change the parameters if one wants to, and then using the apply button that can be added here. Okay, and now in my units different height factors have come. Exposure 0 or 1. 0 is for fully enclosed building, that is no partial release of openings in frame, and 1 for a frame or walls where no pressure will be accepted. 0 means 100% enclosed. So we will be just taking 0, and we can add that, or if we ignore it, then it will be taken as 0 only. I will just delete it. So we have applied a definition for windward in x direction. Now once again we will have to apply for this windward load flowing in x direction, wind flowing in x direction. The same can be applied to using leeward, sidewall, windward, leeward, Z and sidewalls. Thank you.